Hello and good afternoon, everyone. I hope all of you are fit, fine, and healthy. I hope I am audible and visible to all of you. Can you see me, everyone? Yes or no? Okay. So, in the previous class, I think we were doing electrostatics and we had come up till something known as electric field. And what is electric field? Am I audible to all? Can I have reason that we understand that my words are getting on your side? You understand everything? Okay. So we were doing electric field, and electric field is the region in space where a charge experiences electric force. Whenever you have a charge and you place this charge in space, in the region around this charge, it will create a region where if you bring another charge, the another charge will experience a force. That force will be known as electrostatic force. That force will be known as electrostatic force. And that region in space will be known as a region having electric field. Now, who creates this electrostatic field? We call it electrostatic field and not electric field. Who creates this electrostatic field? A charge itself will be creating that electrostatic field. And if you bring another charge in its vicinity, in that region, that another charge will experience that electrostatic force. I also told you in which direction what charges will experience force. If you have a positive charge will experience force in the same direction as that of electric field. But if your charge, if it is negative, it will experience force in the opposite direction of electric field. Electric field, there are some property that you must remember. It is a vector quantity. Direction of electric field is always from the positive charge. Force on the charge is Q into E. It obeys superposition law. Whatever questions you do on electrostatic field, they are question of electrostatic force. If you multiply them by charge, whatever questions you have done for electrostatic force are question of electrostatic field. If you divide them by the charge, yes or no? We have done this, right? Now these are simple formulas that we have derived with the graph. Everyone should know this formula. Electric field due to a positive charge is kq by r square multiplied by r unit vector along the direction of r unit vector. This is how the graph looks like. You must remember both the equation as well as how the graph looks like, because many a times many question has been asked specifically on this graph. So please remember these graphs, how these graphs are drawn. At infinity, if you can see, at infinity this electric field is going to be 0, and at points which are very close the electric field is almost going to be very large. We can call it infinite. Do we understand this graph? Can I have some reason that we understand this, sir? These are the small points that you must remember about this. Infinite long charge. Infinite long charge. You must know this formula. This is R unit vector. If you want to find it here, what you do, you draw a unit vector R like this. If it is positive charge, it will go along this line. If it is negative charge, it will come along this line. This is the electric field created by an infinite long charge. Remember it. From this electric field you can find the electric potential difference between 2 points. To integrate this, you multiply it by dr and then you integrate this. Do you remember that? This is the only way to find out potential difference between 2 points created by an infinite long charge, because for an infinite long charge you cannot find a point whose electric potential can be taken as 0. As I told you, when we are doing electrostatic fields, we are also doing gravitational fields. So you just substitute the value and you will get the answer for electrostatic field. For example, 1 by 2 pi epsilon naught. Remember, 1 by 4 pi epsilon naught was k, and this k is equal to g, which is the gravitational constant. So if you have 1 by 4 pi epsilon naught, this will be 2 times of G. So the formula for gravitational force will become 2 times G lambda by R. Do you understand how I found this formula for gravitational field created by this infinite long mass, linear mass? Lambda is the charge per unit length in this case. In that case, will become mass per unit length. Do we understand this? Can I have some raised hand? How I got this formula for gravitational field? Remember, electrostatic field from positive charge, it is going away. For negative charge, it is coming towards. But gravitational field is always directed towards the mass. It is never directed away from the mass. Do we understand this? This is the graph that you must know how it looks like. Infinite non-conducting sheet. It is sigma by 2 epsilon naught. Sigma is the charge per unit area. You must know this. Again, you cannot find a point where potential is zero. So if you have to find out the potential difference between 2 points, you integrate like this. This is a constant field. So it will be simply sigma by gravitational field symbol beta. You can use G vector, the acceleration due to gravity vector, G vector. Acceleration due to gravity, G vector. For electrostatic field, we use E vector. For gravitational field, you can use G vector. Okay. So now you can devise the formula for gravitational field. Sigma is charge per unit area. Here, there it will be mass per unit area by 2 epsilon naught. Remember, 1 by 4 pi epsilon naught have to be replaced by G. So 1 by 2 pi epsilon naught becomes 2 pi G. So put 2 pi G in place of 2 times epsilon naught, 1 by 2 epsilon naught, and you have the formula for gravitational field. Uniformly charged ring, here we have K. K is that constant 1 by 4 pi epsilon naught. So you can straight away put K ki jagah G, capital G, and you will get formula for uniformly charged ring. If it is a positive ring, it will go away. If it is a negative ring, it will come towards. And this is the graph. And remember, there is a very important point in this graph. Can anyone point me what that point is? And what is the significance of that point? This question has come many times in many papers in different ways. What is that point that you can see? The point that I'm talking about is this point at a distance of r by root 2 aage or r by root 2 piche. And this is the point where the electric field created by this ring of charge is maximum. Do we understand this? Can I have some raised hand? R by root 2 is the point where gravitational field or electrostatic field created by this ring of charge or ring of mass would be maximum. Can I have some reason that we understand this, sir? Most of the questions that we imagine can come, and I can understand can come, will be based on any one of this sort of an arrangement. You have to remember all these shortcut formulas so that you can solve those questions in the actual JEE exam. Then you have uniformly charged, hollow, conducting or non-conducting or solid conducting sphere. Solid conducting sphere, property of conductor, you must remember whatever charge you give, it will always come on the outer surface. A conducting body cannot have charge inside the body, and hence this is the formula. Inside electric field is 0. Outside electric field is kq by r square. Same formula can be made for gravitational field, but remember we don't have conducting mass and non-conducting masses there. So this formula for gravitational field will be for a hollow sphere. Hollow sphere, this formula is valid in gravitation. The other formula is for solid sphere, which is our earth. So the other formula will be for earth. This formula will be only valid for hollow sphere or spherical shell. The electric field or gravitational field is maximum on the surface. As you go away from the surface, the field decrease as at infinity, it becomes 0. Do you all understand this? Can I have some reason that we understand this, sir? The next one is uniformly charged non-conducting sphere or your earth, gravitational field or electrostatic field created by Earth. Outside the formula is same. Inside the formula is directly proportional to R. So therefore, you have a straight line graph, as you can see here. At the center of Earth, gravitational field is 0. At the center of a non-conducting sphere, the electrostatic field is 0. And then it is directly proportional to R. KQ by R cube. For gravitation, it becomes GM by R cube multiplied by R or X, depending on what you are calling the distance as. Are we following it? Is everyone able to follow what I am trying to relate here? Is everyone able to follow what I am trying to relate here? Right? Now, this is a question where the points are given in terms of coordinate in space. It is very difficult to use the scalar formula k cube by r square. So we have to use k cube by r cube multiplied by r vector. And that is the formula that you must use to find out the electrostatic field due to charges placed in space, because that will be the easiest way to find out. So they found out the r vector, position vector of point A with respect to the point B. With respect to point B means the point where you have put this charge. If this charge is here plus Q, and you have to find the field of this point A, you have to find out the value of this vector. This is the position vector of A with the point charge. Do we understand this? Can I have raised hand that we understand this, sir? This is how you can find out electric field. This is how you can find out electric field due to different charges which are placed in space. Yes or no? We understand this? Now, if you have a uniformly charged ring or arc of a circle, it is not full circle, arc of a circle, you can devise a formula for arc of the circle, and you must remember all these formulas, so you can just note down this electric field due to a uniformly charged ring or arc. And the formula for semicircular thing is 2k lambda by r. In fact, the formula is like this. Along x-axis, the field will cancel, only field will be along y-axis here. They have integrated from 0 to pi, so from one side to the other side. If it is not a full circle, if it is only some quarter of a circle like this, you integrate it from this side till this side. Or you can write this as 2 times integral from 0 say pi by 2. This is the general formula that you get. If you integrate it correctly with the correct limits, you can find out due to a semicircle or quarter of a circle or anything which is done. In the previous case, what is the electric field due to quarter of a circle? Then the answer will be, if it is only quarter of a circle, if it is only one side of the circle here, if it is only one side of the circle here, electric field will have two components, one along x, one along y. X component will be integrated from 0 to pi by 2, y component will be integrated from 0 to pi by 2, and hence you will have this answer for quarter of a circle. Do we understand this, or it has gone above our heads? You must remember all these formulae. Please mark my words. If you can remember all these formulae, I am sure that you would be able to do this. I am sure you will be able to do this. Remember this, due to a ring, electric field is maximum at a distance of r by root 2. R by root 2. This is a question taken from SCV. It has come in JEE as well. A positive charge Q is uniformly distributed over a circular ring of radius A. So this is that ring. A point charge of mass M and charge negative Q is placed at a distance of y from the center. Find the force on the particle. Assuming that y is very large compared to a, find the time period of oscillation. So what will be the time period of the oscillation? So how do you do it? How do you do it? The mass is not given here. So you will assume that the motion is taking place in a space where there is no gravity. So mg wala factor, you can assume that it is not there. So you can only find out the forces due to electrostatic field or electrostatic forces The force acting will be Q into E. So this is the formula that they have used. That is the original formula. KQY upon A square plus Y square raised to the power 3 by 2. That is the electric field multiplied by the charge Q. Get the force on the charge. Then the condition is given is A is very large compared to Y. You put this condition, you get this answer. This force is directly proportional to Y, which is the displacement from the mean position, and hence the motion becomes simple harmonic, and this becomes the time period. Do we understand this? What has gone above our heads? Are we following this better? What I am doing? Are we following this? So basically, what we have done, here, beta, is found out the electric field due to this ring. Electric field due to this ring is given by this formula. We have just done this formula. KQY upon A square plus Y square raised to the power 3 by 2. To multiply it by the charge of this body, you will get the force. Then we put the condition that A is very, very large. A is very, very, A distance is very, very large compared to Y. We put that the distance Y, it is given here, beta. Y is very, very small compared to A. So Y is very, very small compared to A. So this equation A square plus Y square becomes simply A square. So we have A cube in the denominator, and this is directly proportional to Y. So F is directly proportional to Y, which is the displacement from the Y axis here, mean position. This becomes the equation of SHM. We put it and we get the equation of SHM, and we get the time period. Am I clear now? This is how you can solve any question on SHM. This is how you solve them. Okay, now please remember such questions. Just I have solved this one for you. Calculate the electric field at a point on the axis which is distance x from the center of a half ring. This is not an entire full ring. This is half ring, just half ring, half of the ring. Full ring, I've given the formula. Everyone knows the formula. What is the formula for half ring? Just remember that this is the formula for half ring. E along x is 0. E along y and E along z. E along y is given by this formula, and E along z is given by this formula. Just remember these two formulae for a half ring at a distance x from the center of this ring. What is the value of electrostatic field along x, along y? What is the value? Look at this diagram and remember these formulae. This is your x-axis, this is your y-axis, and this is your front axis, which is the z-axis. Along these sides, forces cancel, but along y and z, forces do not cancel. We have integrated this. I'm saying forces and field are the same thing. Remember the formula along y-axis. The formula along z-axis is the same formula that we did for the full circle, but the formula for y-axis is somewhat different. Please remember it. Do you understand this? Will you remember this? If this question comes, you can straight away write the answer. Yes or no, we understand this? See, this is the way it is being solved. The entire solution is given. You don't have to go through this entire solution. You can just remember the formula and you can stay happy ever after. Do you understand this? Can I have some raise hand that we understand this, sir? Sudha, Gojraju, Isha, Sai Teja, Vishnu. Do we understand this better? What I have told you? The next one is now instead of a ring, it becomes a disk of surface charge density sigma. What is the formula for this? Just remember the formula, and the formula looks like this. Sigma by 2 epsilon naught 1 minus x square by r square plus a square root, where x is the distance from the center of the disk and r is the radius of the disk. Now, if you want to convert this formula for gravitational field, remember 1 by 4 pi epsilon naught was equal to g. To find the value of 1 by 2 epsilon naught, it will be g into 2 pi. So just put, instead of 1 by 2 lambda 2 epsilon naught, put 2 pi g, and it has become the formula for gravitational field. Now they have used two cases. Case number one, x is very large compared to r. You can remove this term, and you can have the formula like this. We have used binomial expansion here. I hope you understand the meaning of binomial expansion. Everyone understand the meaning of binomial expansion? They have used binomial expansion over here. Do we understand the meaning of binomial expansion? They've used binomial expansion here and they got this formula. If x is very large compared to r, if x is very small compared to r, it becomes infinite sheet. For example, if this is a circular sheet and the point is very close to that sheet, that point will not be able to tell whether this sheet is circular or whether this is infinite. So for points very close, if you have a triangular sheet or you have a rectangular sheet or you have any size of sheet, if the point is very close, the formula will always be sigma by 2 epsilon naught. Do we understand this? Because for a point which is very close, you cannot say what is the dimension of the sheet, whether it's triangular or rectangular or circular. The formula will be same in all the three cases. For example, our earth is not flat, it is spherical, but we don't see the sphere. The what we see, the straight line, is not a straight line, it's actually a curve. But since we are very close to the surface of earth, we cannot understand that the earth is spherical. Same is the case. Some people still feel that earth is flat. Why they feel that earth is flat? Because it looks flat. Why it looks flat? Because we are looking at the earth from a very small distance. As soon as we increase the distance from earth, we go higher and higher up, we will see earth is spherical in shape. Similarly, if a point is very close to a surface, for it, the surface becomes infinite. The shape doesn't matter. So the answer is always sigma by 2 epsilon naught. Please raise your hands and tell me that you understood this. Same question could be asked to you in the examination hall. Then you can thank the classes that you are doing here. You can thank those classes and move on. Now you have this question wherein you have a hole in the disk, a hole in the disk. Now, I always told you, whenever you have a hole in the disk, how do you solve a question of hole in the disk? You assume that there is no hole. You find the electric field or gravitational fields or electric force or gravitational force or electric potential or gravitational potential due to the entire disk without the hole, and then you subtract the part of the hole, and that is what they have done over here. That is what they have done over here. If you see, this is the answer you will get. This is the disk without the hole, 1 minus x of this thing. This is the disk with the hole. The actual formula was 1 minus x divided by x square plus r square ka root. So this is the first without the hole. This is the first. This is the second part of the hole. We subtracted both, and this is the answer that the end you will get. This x comes out. Do you understand how we have done this? Do we understand how we have done this? Assume that there is no hole. You find the gravitational field or electrostatic field, then subtract the part of the hole. Assume that this is complete disk. Find the electric field, gravitational field, subtract it, and you have the answer. This is what they have told you. We can also use the superposition principle, ER plus E small r. First you find the field due to the entire disk, then you subtract or vectorly add the field due to the whole part. Do we understand this? This is the electric field due to a uniformly charged ring. If the point is at the center, the y component here will get cancelled on electric field will be along x, and you will get a formula of this type. Now this formula may also remind you, of formula in magnetic field. Similar formula comes in magnetic field also. Both formulas look similar. If The point is not on the perpendicular bisector. You will have Ex as well as Ey. You'll have Ex as well as Ey. Then you can find out both, and the net field will be Ex square plus Ey square. Please remember these formulas if you can. Here what they have done is they have just taken it as symmetrical. One is angle theta 1, one is angle theta 2. So we don't know the values of theta 1 and theta 2. If both theta 1 and theta 2 are same, then the y component will get cancelled and the x component will be added up. If theta 1 and theta 2 are different, this is the answer that we get along x sine theta 1 plus sine theta 2, along y cos theta 2 minus cos theta 1. If it is become infinite, theta 1 and theta 2 become 90, and then we have this diagram, and this is how it looks like. Everything has been given in your notes. Please go through your notes. For semi-infinite wire, remember, we also have the semi-infinite wire in magnetic field. You put one angle as 0, other angle as 90 in the actual formula, and you get this one. Do we understand this? Now, once you have this formula, you can now do a variety of questions. For example, a point charge Q is created distance R from a very large wire of length L, infinite wire. What is the force? You just find out the electric field and multiply it by the charge, and that is how you get the force. So do we understand this? Remember, JEE will never ask you to derive a formula. It will always ask you, based on that concept, they will make a question that will check whether you know that formula or not. You will only know that formula when you have done that formula, and whether you can apply that concept in the new question. Do we understand this? Now, for example, this question. Now, how will you solve this question? If this question comes, this question can be a question of magnetic field, it can be a question of electric field, it could be a question of gravitational field. Again, I can apply the formula for superposition. I will assume that there is a wire from here to here whose charge is plus lambda, and then I will subtract or add vectorly a wire of minus lambda from here. For this wire of plus lambda, one angle is 0 and the other angle will be this angle 37. For this wire of lambda, one angle will be 0 and other angle will be 90 degrees to integrate. For this wire of minus lambda, one angle will be 0 and the other angle would be 37. I can superimpose these two fields, whether it is electrostatic field or gravitational field or magnetic field. We will have the general formula for these three fields. Put the value of one as 0, other as 90, one as 0, other as 37. Superimpose the two fields and get your answer, and your answer would look like this. Are you getting my point? How did I do it? By the principle of superposition. They have done it by angle. What is one angle? What is two angle? I don't understand them. It becomes very difficult for me to understand them. So any question of this matter, I will always do by the principle of superposition. Have you understood how I applied the principle of superposition here? Have you understood how I applied the principle of superposition here in this question? I assume that this wire extends from here till infinity. So one wire is semi-infinite, and I subtracted the wires from 0 to 37 from that. That is how I've applied the principle of superposition here in this diagram. Please, can I have some reason that we have understood this? How I've applied the principle of superposition in this diagram. Okay, there was a similar question in Irodo, where we have this hollow cylinder. This hollow cylinder has a total charge Q or mass M, and then there is a small slit, infinite slit of with delta x, small slit of delta x that has been created throughout the length of this cylinder. You are supposed to find out the electric field or magnetic field or gravitational field at the center of this cylinder. How do I do it? It's very simple. I assume that this slit is absent, and I assume it to be a complete cylinder. Complete cylinder, what will be the magnetic field or electric field or gravitational field due to this complete cylinder? It will be 0. All the field will cancel each other out. So if the entire field is 0, what do I do? The entire field due to this entire thing with a slit will be the superposition of complete cylinder and that slit. Complete cylinder is 0. This slit is an infinite slit at a distance of r. I can put the formula, find out the magnetic field or electric field or gravitational field due to this slit only. Whatever is the value of this slit, the opposite will be the value of cylinder with the slit. I have again applied the principle of superposition. Wherever I see a cut, wherever I see something which is not full, I will assume that this is full and then I will put the cut. Are you getting my point? I've spoken too much. Have you understood it? Have you understood how I employ the position of the principle of superposition wherever I see cuts? Okay, okay. Now we come to this question. An infinite large sheet of surface charge density sigma is lying in the xy plane. These are the type of question that you can always assume. A particle having charge minus q and mass m is projected, making an angle of theta. Find the time taken by the particle to return to the plate, maximum height, at what distance will it strike the plate. Does this question remind you of something? Forget about that. This is a question of electric field. If there is no sheet and this is ground and there is no charge and this is mass, what does this question become? What does this question become? This is the question of projectile motion. Yes, right? The acceleration due to gravity was g. Here it will be QE by m. The acceleration. Q is the charge, E is the electric field. What will be the electric field? Electric field will be electric field due to an infinite sheet. Sigma by 2 epsilon naught. You put the values and you get your answers. Do we understand this time period? Not time period. Time of flight, 2u sine theta by g. Maximum height, u square sine square theta. Maximum range. Do we understand this or it has gone above our heads? Do we understand this, how it is done? Can I have some reason that we understand this, sir? Nothing. Just put the value of g as what I have told you and you are done. Am I clear? Everyone understand this? That is great. Now, once you know the electric field due to one sheet, now you can do this question. If there are three conducting parallel sheet, infinite sheet at a distance, very small distance, what is the electric field at point A, B, C, and D? How will you do question of this type? Now, there are two ways of doing this question. The first way is to find out the charge on each side of the sheet. That becomes long. You find the charge on this side, you find the charge on this side, you find the charge on this side, this side, and this. It becomes quite lengthy. How you do it? You can just assume that this is one sheet having charge Q. Its charge will always remain Q. Another sheet minus Q, another sheet 3Q. Find the electric field of this sheet, sigma by 2 epsilon naught. Find it due to this sheet, sigma by 2 epsilon naught. Find it due to this sheet, sigma by 2 epsilon naught. Positive charge, positive sheet, it goes away. Negative sheet, it comes towards. Add them vectorly, you have your answers. For example, at point number A, electric field due to plus Q charge will be going like this one. Due to minus Q charge will be going like this one. Due to plus 3Q charge, it will go like this. You add electric field due to plus Q and 3Q, subtract the electric field or vectorly add the negative field, and that is your answer. Electric field to the plus Q charge is sigma Q by 2 epsilon naught. Sigma is Q by A. Second is 3Q by A, sigma by 2 epsilon naught. Third is 2Q by A, sigma. And we have our answer. Do we understand this? Do we understand this? Can I have some raised hand that we understand this? How I have done this? Similarly, if the point is here, electric field due to this charge will go like this. Electric field due to this charge will go like this. Or the electric field due to this charge will go like this. You add them, two fields are this side, one field is this side, you will get your answers for the next point. See, point B, minus 2q is going here, plus 3q is going here, 3q plus q is going here, plus 3q is going here. You subtract and add, and you get the net field. For point C, plus q wala field will go here, minus 2q wala field will go here, plus 3q wala field will go here. Two fields are on this side, one field is on this side. You can add, subtract, and get your answers. Am I clear? Am I clear? Can I have some raise hand that you understand this, sir? Okay, now you have this question. Thin infinite sheet of width W contains uniform charge distribution sigma. Find out the electric field. A point which lies on the same plane at a distance D. A point which is on the symmetry plane at a perpendicular distance A. So basically one point lies here somewhere from one of its edge, and the other point lies above this sheet at a distance D. Now how do you solve this question? Don't solve this question in the examination hall. You know this question, you can straight away. Basically what we got to do is break this sheet into small parallel wires. Find the charge on any parallel wire. Use the formula for electric field due to an infinite wire. Integrate this, get the answer. So this is the answer for point on the edge at the distance D from the edge of the disk. If you have perpendicular point, you take one element here, field due to this will go like this, field due to this will go like this. These two parts will get cancelled and you will have 2 times d cos theta ka integral. This will be the answer. If this sheet also becomes infinite in this direction, your answer will again reduce to sigma by 2 epsilon naught. You can check this when you have time. Because if it becomes infinite sheet in this dimension and infinite sheet in this dimension, it becomes an infinite sheet. And for an infinite sheet, the answer is always sigma by 2 epsilon naught. Now we have questions on electric field due to a uniformly charged spherical shell. This uniformly charged spherical shell is same as uniform mass spherical shell. Inside electric field or gravitational field is 0. Outside it is same as a point charge. You all know this formula. You can use these formulae to find out. They have just calculated this electric field here. We don't need that formula. We already know that formula. So we'll just skip this part. There is no point of doing this part. The point on the left and on the right. There's no point of doing this. We'll just solve this problem, question number 42. These are the type of problems that might get you trouble in the examination hall. So please see them carefully. This figure shows a uniform thin sphere. Thin sphere means it's a hollow sphere of total charge Q and radius R. At point charge Q is situated at the center of this shell. Find out the following. Force on charge Q. What is the force on charge Q? Force on charge Q. Inside the shell, electric field is 0. So force on charge Q will be 0. Do we understand this? Yes or no? The electric field at the center of the charge, at the center of the shell is 0. So force will be 0. What is the electric field at point A? If you want to find out the electric field at point A, it will be only created by this charge because inside, because of this shell, the electric field is 0. So you just find out the field due to discharge and you have the answer as kq square, kq by r square. Outside, if you want to create find out electric field, find out the electric field with this shell, superimpose the electric field with this shell, this small point charge, and you will have the answer, and this would be the answer. Yes or no? We understand this? Now we'll be doing again, doing this question. When I tell you something known as the shell theorem, we'll come back to this question when we are doing this shell theorem. Okay. Do you have any idea what this shell theorem is? Okay. This one. Find the force acting between two shells R1 and R2 which have uniformly discharged charge Q1 and Q2 and distance between their centers is R. So what will be the value for this? It will be same as, you can replace this by 2 point charges, one placed here, the other placed here. So K Q1 Q2 by R square. The question is simple. So whenever you have a question like this, you should be able to solve it perfectly. Now you have this question. A uniformly charged solid non-conducting sphere of uniform volume density rho. So now charge is distributed inside this thing, and radius r is having a spherical cavity. Find out the electric field at point A, B, C, and at the center of the sphere. Center of the sphere, the answer is 0. At point A, Gauss law, you also know Gauss law. Answer is 0. How will you find the gravitational field at point B or electrostatic field at point B? Now this is sphere with a hole. So what do? You can apply my formula of that full sphere, and you have that hole, or you can apply Gauss law. They have done this question by Gauss law. Electric field is only due to the charge which is present inside this sphere. You find out this charge. Remember what is Gauss law? E into kya? Integral of E dot ds, something like this, na? Integral of E dot ds is q by epsilon naught. Yes or no? So you can apply that formula and you can get this answer. Yes or no? You understand this? So this is one way of doing it. Or method number 2, full sphere, subtract this sphere, and you have this sphere. You find the field to this sphere. You find the field to this sphere. You add these fields together, and you get your answer for the final sphere. You understand this? Yes. Now, there could be a question of this nature where you have the surface, the volume density changing, variable volume density. Now, if there is a question of variable volume density, how do you do this question? You will do this question. Either you can do it by taking shells and finding out the charge inside the shell, or you can do it using your Gauss law. Integral of E dot ds is equal to enclosed charge divided by epsilon naught. This ds will become 4 pi x square, where x is the radius where you have to find it, and this is the total charge enclosed inside this sphere. How will you find the total charge enclosed this sphere? You take a shell of radius r, the area becomes 4 pi x square dx, the volume becomes 4 pi x square dx. You multiply it by rho and you integrate it from 0 to r or 0 to x, and you will get the total charge inside this shell or sphere, and you should be able to calculate the electrostatic field at this point. Am I going too fast? See, up till now we have only covered electrostatic field due to all types of charge distribution, starting from the point charge to line charge to what you call sheets. Then we moved on to spheres, shells and spheres, and that is how we move. So the last point of this class, and in the next class we'll be discussing it in detail, is electric potential. Electric potential. What do you mean by electric potential? Electric potential and gravitational potential are same. Electric and gravitational fields are same. They are potential fields. To move from one point to other point, if you move a charge or a mass in a gravitational field or electrostatic field, the work done does not depend on path. It is path independent. We call these fields as potential field or conservative fields or conservative forces. The work done in moving a charge from one point to another point does not depend on path. So we can call it as change in energy. Change in energy is negative of the work done. I already told you that. Yes or no? And if you divide this work done by charge q or mass m, this becomes the change in potential or change in potential. So potential and potential energy are related to each other. Change in potential is change in potential energy divided by mass, or change in potential energy divided by charge. Do we understand this? Can I have some reason that we understand this? The difference, the relation between potential and potential energy is same as the relation between force and charge, because electric field is force divided by charge or force divided by mass. Here in place of du, you have F, and in place of dV, you have E. And what is the relation between E and dV? E dot dr integral is minus dV. You must also know this relation between electrostatic field and electrostatic potential difference, or gravitational field and gravitational potential difference. Are you aware of this relation or not? Please tell me. Or have I gone too far? Do you know this relation? Yes or no, beta? Am I audible and visible to all of you? Can you see me better? Okay, fine. I get confused if I don't get responses, I get confused. It's become difficult for me to come back. Okay. Properties of electrostatic potential or electrostatic potential energy. It is a scalar quantity. It can be positive, negative, or zero. When they are talking about potential, they are talking about potential difference. Remember, absolute value of gravitational potential or absolute value of gravitational potential energy or absolute value of any potential energy or potential is not defined. To define absolute values, we must have a point whose potential or potential energy can be taken as zero. In most of the cases, that point can be taken as infinity, but in two cases, particularly two cases, we cannot find a point whose potential or potential energy can be taken as zero. What are the two particular cases in which we cannot find those points? We have already seen those cases. We have already seen those two cases in which electric potential or electric potential energy cannot be taken as zero, because we cannot find a point where electric potential or potential energy is zero. What are the two cases? Can anyone tell me where you cannot find the absolute value of electric potential or gravitational potential, because there is no point where that potential is zero? What are the two cases? We have already seen it. Anyone? I told you when we were doing it in the beginning of the class that remember, these are the two cases where you can find out the gravitational potential energy by integral. Do we remember this? No, we don't. If you don't, then here it comes. Infinite long charge. You have infinite long charge or an infinite sheet. You cannot find a point. You cannot say the potential at infinity is zero. Potential at infinity is not zero here. You cannot find a point whose potential can be taken as zero. And therefore, to find the gravitational potential, I told you, you have to integrate electric field with dr and integrate it from one point to other. You will never get the value of absolute gravitational potential or absolute electrostatic potential. You will always get the value of gravitational potential difference or electrostatic potential difference between the 2 points. Do we understand this? Can I have some raise hand that we understand this, sir? Can I have some raise hand that we understand this, sir? So there are only there are two particular cases in which you will not be able to find the absolute value of electrostatic potential or absolute value of gravitational potential, because there is no point where you can assume the potential to be zero, and therefore those points you will find gravitational potential difference. And how will you find out the gravitational potential difference? By the integral of electric field with dr. In the next class, what we are going to do is we are going to go ahead and deal in potentials. Deal in potentials. We have already we have already started the topic of potential. We'll be dealing with the potentials of some type of charge distribution. So we'll be going in detail and studying these charge distribution. I would be very glad if you can go through this table. Almost whatever you require is given in this table. Electric potential due to a point charge. We are calling this as absolute potential because there is a point whose potential is taken as in zero, and that point is infinity. As you can see, the graph also tells us clearly that potential at infinity is going to be zero. Similarly, for a ring, potential at infinity, as you can see specifically at infinity, the potential is zero. For a sphere also, potential at infinity is taken as zero. We can very simply see it. For a sphere, non-conducting sphere also, potential at infinity is zero. You can very well see it. Now see, now see, now see. This one, see, there is no graph here because there is no point whose potential is infinity, and therefore you have potential difference between 2 points. Do we understand this? Can I have some reason that we understand this, sir? No doubts. You are trying, you are making some sense now. Why there is, you have to integrate electric field with dr. Infinite non-conducting sheet, again there is no diagram here. You can draw a diagram, not a problem, but there is no point whose potential at infinity cannot be taken as zero, because you cannot have a point whose potential is zero, and therefore you can only find the potential difference between 2 points. Do we understand this? In the next class, we will be dealing with potentials and potential energies. If you can go through these diagrams, that will help us a lot. So in today's class, in 2 classes, we have come up the potential. That's good. We'll try to wrap up electrostatics and capacitance, then move on to electric current, then magnetic field, then EMI. It will take some time. After that, we'll move on to thermodynamics, because these are the 2 topics which I feel are the most scoring ones, and thermodynamics also comes in chemistry. So that is an added advantage. We'll do that. Then probably we'll move on to modern physics, and then optics, and then the rest of the topic. So we'll call a wrap for today's class at this point in time. I hope you enjoyed this class. And if there's anything that I can help you with, you can always reach me. I'm here in the class. If there's anything, you can ask me. Else, from my side, I have dismissed the class. Enjoy your life. Take care.